Hi there, and welcome to another video of Made with Cables. My name's Mark, my handle on the forums is Andro, and today I'm going to be showing you how to use our new Lsystem generator op. So, to get started, we'll make a main loop. We'll connect this to an orbit controls, which will allow me to use the mouse to move around in 3D space. We'll then connect this to a transform. We'll finally connect this to the Lsystem op. Now, to get things started, if you click the Lsystem op and then click View Documentation, this will take you to our documentation page. Here we can see a tree, which was created with the operator. And here is like a little basic explanation of what an Lsystem is, and our convention on how this is used. So if you want more in-depth information, please feel free to look here at the bottom. We've got a nice web link to a brilliant page from Bourke, whose resources are invaluable in creating this op. Okay, so we're going to go into full screen mode. So if I click the Lsystem, we can see that we have a lot of different controls here, but we don't see anything. Now the reason for this is we're going to use an Lsystem to either draw geometry, or a point cloud, or a mesh, or we can do them all together. So if I go here, and I hover the mouse over this output part, I see out trigger geometry. I'm going to pull this out, I'm going to make a triangle, and we can see over here right now that I have some triangles, and it looks a little bit like a simple tree. So I'm going to click on the triangle, I'm going to put the width on 0.25, and I'm going to put the height on 0.5. And now I've got more of a clue what's going on. Now if I go to the Lsystem, this is one iteration by default. If I click here, we now go to 2, and we see that it generates more branches and a more tree-like structure, but it's going off the screen. So we've got a little trick for this. If you click the Lsystem op, make a divide op, go to this outlet, max size. This is the maximum distance from the center of the Lsystem. I'm going to plug it into number 2. I'm going to get the output of this, and I'm going to plug it into scale with transform. Now it looks like the tree has disappeared, but it hasn't. We click divide, and we pull this number up, and now we see the tree. So if I now change the amount of iterations from 1 to 2 to 3, it stays on the screen. So this is a great way to follow what's always happening with your Lsystem. So I'm going to explain a little bit what's happening here, but it's just going to be better to do it from scratch. So first of all, let's give this triangle a basic material so it becomes a little bit easier to see. I'm just going to make it white. There we go. So if you click on the Lsystem, we have a lot of parameters here, which can do a lot. Don't worry, a lot of it is really simple to understand if you read the documentation, and I'm just going to start from scratch to show how things go. So basically you always need an axiom, which is a seed, which is the first part of the string. You need a constant and a rule. That's the basics to go, and the extra constants and rules are handy if you want to generate more complex systems. But trust me, one rule can already be complex enough. So the thing I'm really interested in at the beginning is the default angle. So I'm going to put this on 22.5. And just to show you what's happening here, if I now tweak this angle, you can see that everything changes real time. So I'm going to put this around 22. And this is what we're interested in, the rule. So I'm just going to start something from scratch now. So I'm going to delete this, and we won't see anything. Now, if I put in a capital F, we draw a triangle. If I put in another one, we draw 2, 3, 4. Great. So capital F means take a step defined by step length, which is 1, and then draw a point, which in this case is a triangle. Now, let's say I want to rotate to the left. If I do X and then F, as you can see, it's now rotated to the left. Now, if you put in one letter, which is X, Y, or Z, it will rotate by the default angle amount. So if I now go up here and type in Y, X, F, F, as you can see, we have a tree. Put it on 2, we get a really crazy shape. And this is where it becomes pretty complicated to control. So I'm going to leave it on 2 iterations now, and we're going to start something a little bit more sensible. So you can also type in an axis ladder with a number, and then you define how much it rotates. So I'm going to do Y, 3, X, 4, F. So now X and Y are not rotating by the default angle, they're rotating by a user-defined angle. So this is where it gets interesting. We're now going to create a branch with these 2 symbols. So I'm going to do this. And as you can see, we now have branches on the tree. And the branches, they're kind of independent from the main string. You better read the documentation for more about this. But I'm going to create another branch which has the same instructions, so it's not going to do anything. But if I do Z in the other direction, as you can see, we now have the basics of a tree with just a few characters in a string. If I now go to iterations and put it on 3, we get a more complex shape. So let me zoom out a little. And if I go here to default angle, as you can see, I can change this and animate it. So it's pretty cool stuff. Rotation multiplier rotates all angles by that amount. So you can get some really crazy stuff going on here, which goes really into the world of generative. So I'm going to just put this back on 1. We also have the random seed and the random strength. This allows us to create randomness with the placing and the scale and the orientation of the tree. Creates a lot of different outputs. So this is the basic Lsystem. The last thing I want to show you is how we can use this with splines and with points. So here we have another output, and this is reserved for the line or point ops. So I'm going to go here and I'm going to say point cloud. Visualize an array of coordinates as points. So I'm going to do this. I'm just going to disable the triangle for a minute. We're not seeing anything yet because this still expects an array. Here we have points out. I connect this. Sorry, one moment. Let's connect this back again. That was my mistake. I need to make a point material. And these mistakes are good to make. They show how things are. Point cloud array. I'm going to connect this here. Okay, there we go. So now we're not seeing the triangles, we're seeing the points. Now, I'll just show you what we mean here. So now we have a point cloud from array. And here we can change the point size. And we can do some really nice stuff like random size. So if I'm going to put this on 1, and turn the random up, we get this nice different effect. So we can also use the same output here from this to render a spline. So I'm going to say spline, simple spline. Let's get this one. Let's give it a material. And now let's connect this. I'm just going to disconnect the points for a moment. Once again, simple spline like point cloud from array expects an array. We put this in. And now it's drawn as a spline. You can also use spline mesh if you want to define the thickness. So if I go to simple spline here and I start drawing with this number, we can draw the spline out, which gives a really cool effect. So you can do all of these at the same time if you want. And if we just change the colors so they're separate, we're going to make the triangles red. We're going to make the point cloud green. Terrible colors, but it makes it visible. And we're going to make the simple spline blue. And now you can see that we've got everything together. I'm going to reduce the opacity for a moment so we can mix it all up. Now, no one said it would look pretty, but it gets the point across. So this is a nice example of what you can do. And now I'd like to show you like something we can do which is like a lot cooler, because this is just a basic tree, which is really nice. So there was something that I was working on that's going to be available as a public patch later on today. So first of all, I'm going to go to the Lsystem and I'm going to change the rules. These I already put together, so I'm just going to copy paste them for a moment. Okay, so what are we looking at here now? First off, this isn't correct because my angle is wrong. So my default angle is 60. And my step scale multiplier is 1.005. I'll get back to that in a moment. Step length is 1. That's fine. So first off, I want to just do this. So we're drawing a lot of triangles here, but what I want to visualize is the spline. Now if I go to the simple spline and I put the number back on 0, all of a sudden we get a really cool geometrical form. This is what I came up with my rule set. I'm going to put it on 4 iterations. Now, as you can see, it's all very solid. A little trick to make this look a bit cooler is to reduce your alpha. So I'm going to make this all a little bit brighter, and then I'm going to reduce the alpha so we get some opacity going on. Now I'm going to add the point material. So I get the output from line point trigger. And I'm also going to make this a kind of white color. I'm going to make it a little bit more blue. And I can also reduce the opacity here. Okay, so now we've got these points which are at each position from the Lsystem. So now I want to replace the triangle with something cooler. So I'm going to get a cube up. I'm going to connect the trigger out. Now we get this huge amount of cubes, which are a little bit on the big size. So I'm going to do this little trick. I'm going to put the width on 64. I'm going to put the height on 0.1 and the width on 0.1. Still not enough. 0.001, 0.001. Cool. Okay. Now I'm going to put the material brighter. And I'm also going to make this a little bit more blue. And I'm going to turn the alpha down. So as you can see now, I've got a pretty cool looking generative piece here in cables, which is just literally made in a minute or two. So I'm going to turn the alpha down a little bit with the balls, the points. And as you can see, we get some really trippy visuals here. Now, you can go into the system and you can start tweaking it how you see fit. If I change the rotation multiplier now to 2, then instead of it being 60, it'll be 120. But if I put it on 1.5, we just end up with a wildly different look. So I can just click and drag this and see what's happening. Let's turn off random. So if I put this in 0.5, all of my angles here are actually 30 degrees. So everything's kind of like flown off the screen. So I'm going to use this. Now, I didn't say it looked pretty, but it is experimental. And this system lends itself to creating really beautiful geometric forms, but you're going to have to play around with it and like figure out how this works. So let me get back into position with my orbit controls. Now, if I want to just have this rotate around, I can just make a timer 2. And I'm just going to connect that to rotate X. That's already looking a lot cooler when it's animated. I'll make another one. I'm going to put the speed on 2. I'm going to put this on rotate Y. And now we're going to start flying through this space. Any of these geometry shapes here can be swapped with something else. So I could put something else here as well, like the triangle. As you can see, there's so many of them that they're overlapping a lot. If I turn the alpha down, we all of a sudden end up with this. There's so many different ways that you could use this op. I'll just disconnect this. So I'll turn the alpha back up. So this is just a little sneak preview of some of the stuff that you can do with the Lsystem op. It's all about going in here, creating an axiom, a seed, and then a rule. And then just tweaking these until you get something cool. I'd fully recommend checking the webpage of Paul Bourke and our documentation. I hope you've enjoyed this video. If you've got any questions, please feel free to post them underneath or to ask us something on the forum. It's an experimental op, so if you've got any feedback, something you're missing, or something you think that could be implemented, please feel free to send us an email or post it in the Slack group. Thanks for your time. Have a good day. Bye.